we're the brain cells, and today we will be explaining and thoroughly diving into the world of Arduino. By going through a series of projects, we will be completely explaining step by step how to assemble and how the code works for a certain projects in this series. We have Sir Caleb Grimpula, who will be assembling, and Sir Achazo to be our editor and videographer for these videos. And we have Sir Ace Canedo as our primal coder. And me, lastly, as your host and explainer for the code, Mr. Saigon. And without further ado, let's get started. Cells presents Project 6 Alarm.
The material list is jumper cables 2 and buzzer 1. The tone function sends frequency to the buzzer, producing sound to generate sound using tone and exploring analog output.
Hello everyone, my name is Johnny Stephen D. Saigon, and today I'll be the one to explain how Project 6 will work. So, first up, the program starts with variable declarations. A floating point variable named SynVal is created to store the syn value, which will later be used to calculate the shape of the sound wave. And then, another variable underneath SynVal, ToneVal, is declared as an integer to hold the actual frequency value that will be sent to the buzzer. Now, these variables will work together. SynVal will provide the smooth wave pattern, and then ToneVal will translate that pattern into a usable pitch. Next, in the setup function, the program will prepare the hardware, which pin 8 is set as an output using pin mode 8 output. Now, these tell the Arduino that pin number 8 will control an external component, which in this case, a buzzer or a speaker. Now, no other setup steps are needed since the rest of the program's behaviors will run repeatedly inside the loop. And comes the main action, which happens in the loop function. Here, the code uses a for loop to sweep through angles from 0 to 179 degrees. Each angle is converted into radians and passed into a sine function to generate a smooth wave-like value. Now, that same syn value is scaled and shifted into a frequency between 500 Hz and 1500 Hz, which is then stored in the variable ToneVal. Now, the tone function then sends this frequency to the buzzer, producing a hearable or functioning sound. Now, a short delay of 2 milliseconds is added to smooth out these transitions. Once the loop finishes, it will restart automatically, creating a continuous rising and falling.
So in this project, we put the buzzer first on the 5th and the 6th pin on the breadboard. We use the jumper wire to power this. One is to the ground and one to the cathode side. And here it's done.